Hello, how are you guys doing today? Today we're going to learn about quotient of powers rule, or dividing powers rule, or when we have to divide variables that have exponents. So in this example here, it is done for us. We see that the numerator, or the top of the fraction, is x to the fifth power. So that means they have 1, 2, 3, 4, 5 x's in the top of our fraction. And the denominator, we have x to the second power, or x squared, which means we have x times x. Now, when we're dividing, what we're really doing is those x's are canceling out. So the x would cancel out that x would cancel out that x. And then we can count up how many x's we have left. We have 1, 2, 3 x's. So that means that our answer would be x to the third power. There's an easier way to do this. It's a rule that we can use when we're dividing exponents. And what we can do is subtract the two exponents. We subtract the numerator from the denominator. Numerator from denominator. So my numerator had a 5, my denominator had a 2. So 5 minus 2 equals 3, so we have x to the third power. And we got the same answer as from when we expanded it or when we did the rule. In example number 1 here, we have 5 to the third power over 5 to the first power. So 5 to the third power means that that 5 is going to be multiplied by itself 3 times. So 5 times 5 times 5. And the denominator, we have 5 to the first power, which means there's 1 5. And we know that those will cancel out with each other. So I can see that first 5 and the 5 in the denominator will cancel out. Then I can add up what 5s I have left. I have 2 5s, so that will become my exponent, which leaves us with 5 squared. And we know 5 squared equals 25. All right, let's go on to number 2. Number 2, I'm going to expand it out so we can see that our rule makes sense. So on my numerator, I have b to the fifth power, which I know is b times b times b times b times b, 5 b's. And I also have a c in my denominator, so it's times c in my numerator. In my denominator, I have b to the fourth power, which I know is b times itself 4 times, so I'll have 4 b's. And I also have c to the fourth power. C to the fourth power means I'm going to have c times itself 4 times. All right, and then our rule, we know that these could cancel out. So those b's would cancel out, these b's would cancel out, these b's would cancel out, and these b's would cancel out. And I'm left with 1 b in my numerator. And then I can cancel out my c's. I see that this c and this c would cancel out. So now that I have it canceled out, I can simplify and count up what I have left. In my numerator, I have b, and in my denominator, I have 3 c's. So that 3 becomes my exponent. So my simplified answer is b over c to the third power. All right, and number 3, it says we want to use the rule. So now we know that we're going to use the rule. So when I have coefficients in front of variables, like 10 and 5, I can treat those like normal division. I can do 10 divided by 5. And I know 10 divided by 5 is 2. When it comes to variables or unknown values, we have to use the rule. So on the numerator, at the top of the fraction, I have m to the second power, and in the denominator, the bottom of the fraction, I have m to the ninth power. So what you do is numerator exponent, which is 2, minus denominator exponent, which is 9. And I know 2 minus 9 gives me negative 7. If you recall back to our previous classes, we know we can't have a negative exponent there, right? So we have to flip that. We have to move it from the numerator to the denominator. So we get 1 over m to the 7th. But we don't have 1 on top. We actually have this 2, because that 2 is from doing 10 divided by 5. So our answer would be 2 over m to the 7th. All right, on example number 4, it says use the rule only. So we know the rule is that we're going to subtract the numerator from the denominator. So my numerator is negative 5, and I'm going to minus it from my denominator. And my denominator just has x. There's no number there. But we know when there's no number there, there's really a 1. They just don't put the 1 because something raised to the first power just means that there's only one of them. So what we have to do is -5 from the top of our fraction minus 1 from the bottom of our fraction, and -5 minus 1 is -6. Think back to our other classes. Remember, we can't have that -6 as an exponent, so we can simplify it more. The way we can do that is moving it to the denominator or the bottom of a fraction. So the simplified version of this would be 1 over x to the 6th power. All right, let's look at example number 5. Number 5 looks like a big, long, intimidating expression there, but it's not that bad when we break it down. So we're going to use the rule here and simplify it. So the first thing I see is I see these numbers. Those numbers I can divide like normal. Those are just numbers. They're coefficients. And I can do 3 divided by 6. 3 divided by 6 is a half. So the way I would write that is the 1 would go in my numerator and the 2 would go into my denominator. My next thing is I have these x's. So I'm going to use the rule to figure out the x and simplify those. So I always do the numerator minus the denominator. So my numerator has an exponent of 10 and my denominator has an exponent of 6. So I can do 10 minus 6. And 10 minus 6 is 4. And since it's positive, that's going to go in my numerator, or the top of my fraction. All right, then I have another variable here. I have y. I have y to the -2 power in the numerator and y to the -6 power in the denominator. So I can use my rule, -2 minus -6, and figure out what that would be. I know if I'm minusing a negative, we learned this way back when in math, but keep, change, right? Minusing a negative is the same as adding a number. So -2 plus 6 will give me 4. So I have y to the 4th power. And that's positive, so I would put that in the numerator, y to the 4th. So I can make that look a little cleaner. Let me rewrite it. So on my numerator, I would have 1 times x to the 4th times y to the 4th over 2. That would be my final answer. I could also rewrite it without this 1 here, because anything times 1 is itself, so that 1 technically doesn't have to be there, but I'll leave it in there for now so you guys can get it down in your notes. All right, the next rule we have is called a power of a quotient rule. And we learned this kind of goes hand in hand with a power of a power rule. So what's happening here is this y divided by z squared is being raised to the power of 3. So what that means is y divided by z squared is happening 3 times. So what does that mean? That means I have 1, 2, 3 y's. So that's how I got that y to the 3rd power in my numerator. In my denominator, I have z squared, z squared, z squared. And we know that z squared means z times z, z times z, z times z. How many z's do I have? I have 1, 2, 3, 4, 5, 6 z's. So that's how I got z to the 6th power in my denominator, the bottom of my fraction. All right, in this example over here, the same problem as this over here, but it's going to be showing the rule. So the rule is that exponent on the outside gets distributed to everything on the inside. So that leaves us with that y getting that 3. So remember back from power of a power, we multiply with the variable that's already, or the exponent that's already there. So there's nothing written, so really there's a 1. So we know that's 1 times 3, and 1 times 3 is 3. So we have y to the 3rd power, which is the same as we got over here. And then in the denominator, we have z to the 2nd power. And we're going to distribute that 3 to it. So that means we have to multiply it. 2 times 3. And 2 times 3 is 6. Z to the 6 is in our denominator, which is the same thing we got over here, which is good. All right, to raise a quotient to a power, raise the numerator and the denominator to the power and simplify. So in our example 1 here, I'm going to expand it out. So I have x to the 3rd over y to the 1st raised to the 2nd power. So that x to the 3rd means I have x times x times x on top. Y to the 1st means I have 1y in the bottom. And it's being raised to the 2nd power, so that means it's happening twice. So I have x times x times x on the numerator and y in the denominator. So then I can count up how many I have. I have 1, 2, 3, 4, 5, 6 x's. So I have x to the 6th power in my numerator And then I have 2 y's, which give me y to the second power, or y squared, in my denominator. Alright, pause the video and try numbers 2 and 3 by yourself. Get it checked by me when you are done. Alright, example number 4, it wants us to use the rule. So the rule states that we can take the exponent on the outside and distribute it to everything on the inside. I'm going to start with the numerator. So I see that 2, and that's going to become 2 to the third power. Because there was a 1 here, and 1 times 3 is 3. And now I have my f. My f is already raised to the third power, so now I have to raise it again to the other third power. So that'd be 3 times 3, which gives me f to the ninth power. And then I can bring it to g. And g, I see, is already have an exponent of 4, and now I have to distribute that 3 to it. So I do 4 times 3, which leaves me g to the 12th power. Alright, now I have to distribute that 3 exponent to my denominator. I have it highlighted in yellow here. It has to go to everything down there. So I have 3 raised to the third power. And then I have my f, and it already has an exponent of 5, so that means I have to multiply it by the new power of 3. 5 times 3, I know, is 15, so that will give me f to the 15th power. And then I have g, which is already raised to the power of 2, and then now we're raising again to the power of 3, so we have to multiply those 2 exponents. 2 times 3, I know, gives me 6, so I have g to the 6th power. And all that equals, I can rewrite it under this fraction, is 3 to the third power is 27, f 15 we figured out, and g 6. So now I can simplify this more. So 8 divided by 27, those are numbers, I can just divide those. When we divide them, we get a big long decimal, so we can just keep it as a fraction, 8 over 27. Now I can do my f variable. Remember, we do numerator minus denominator. So 9 minus 15. 9 minus 15 gives me negative 6. So since it's a negative, I'm going to put it in the denominator of my fraction. So I put it in the denominator of my fraction to make it positive. So I have a positive 6. Now I can do my g, and I see my g there. I do numerator minus denominator, 12 minus 6, and I know 12 minus 6 is 6. And that's a positive 6, so I can put that in my numerator. So that would be g to the 6th power. So my final answer is 8 times g to the 6th power over 27 times f to the 6th power. Alright, pause the video and try either the odd or even numbers attached to your notes. Check with me when you are finished. Alright, look back on the Google Doc and complete the classwork.